for a logarithm. So I'm going to pick, let's go with -1, 0, and +1. Okay, plugging those into my calculator, let's see what we get. Okay, so here we go. This is going to be, let's see, where is e? So you're going to go second natural log, and that should give you e to some power. So we're going to go with -1, and what do we get? Right there. We'll just go 2 decimal places, so 0.357. Okay, let's go ahead and do that again. So we're going to go second natural log, hit that, we get e. We're going to go to the 0 power, which actually we already know that, that's going to be 1. So e to the 1 power, we'll go with 2.72, which we already knew was what we used for e. Okay, so graphing these, let's see. So 0.37, almost a half, -1. 1, 0. And 2.721. So 2.72, almost 3, and 1. And our vertical asymptote, x equals 0. All right, so there's the parent function. So let's go ahead and describe the transformations in the proper order. So let's see, starting inside with the parentheses first, we're going to reflect about the y-axis. Okay. Second, we're going to reflect about the x-axis. Okay, that negative over there. And lastly, we're going to shift up 1 unit. All right, so reflecting about the y-axis, that means we're going to multiply all of the x values by -1. So this is going to be -2.721. That'll be -1, 0. And this one would be -0.37, -1. Okay. Then we're going to be reflecting about the x-axis. Okay, so we did that. Reflect about the x-axis, that's going to be, let's do that in green. So it means we're going to multiply all of the y values by -1. So this would be -2.72. Oh, I should just do this. This is getting messy. I'm going to just fill this in the table. So it's -0.37, -1. Okay, you know what? Wait. I don't want to be doing all of this on one graph, so let me just erase these points here. Yeah, okay, so for 1, we had the points. So taking the negatives, that'd be -0.37, -1, -1, 0, and -2.721. Reflecting about the x-axis, that means we're going to take the negatives of all the y values. So that's going to be -2.72, -1, -0.37, +1, and -1, 0. Lastly, shifting up 1 unit means we're going to be adding 1 to all the y values. So that'll be -2.72, 0, -0.37, 2, -1, 1. All right, let's go ahead and graph that. So -2.720, right there. Oh, let me do this in a different color. Let's do pink. -0.37.2, so -0.372. And the last one, -1, 1. Okay, so graphing that in. So the question is, what happened to my asymptote? Okay, so when we reflected it about the y-axis, it stayed. When we reflected about the x-axis, it also stayed. But then we need to shift up 1 unit. Ah, still stayed. Okay, so here we go. All right, so yep, all right. State the domain and range. So the domain is going to be negative infinity to 0. Oh, that's the domain of f. And the range of f is going to be negative infinity to positive infinity. Okay, there we go. All right, so now we're going to find the domain. Okay, so the one thing that you have to know for logarithmic functions, this thing in the middle right here is called the argument. The argument must always be a positive number. So I like to think in life, all your arguments should actually be positive. They should all be constructive. You should be trying to find an answer, not just arguing for the sake of arguing. So in life, your argument should be positive. So for logs, you need a positive argument. That means I need to make sure that any x value I plug in here to my argument, it cannot make my argument negative. So that's what I'm going to check for my domain. So I know I need x squared minus 4 to be greater than 0. Okay, solving for x squared. All right, well, x needs to be greater than plus or minus 2. Oh, look, I did something wrong here. Notice this is the instance where we need to do test points. Okay, so I'm going to actually factor this out. Okay, and now I'm going to need to do test points. Okay, because it's quadratic inequality. Okay, so my test points, my critical values are 2 and negative 2. And here are my binomials. And in the end, I want my sign to be greater than 0. All right, so test point, let's go negative 10, 0, 10. Go ahead, fill out this test point and see what our intervals are. All right, so that's going to be negative. Negative sign is going to be positive. Greater than 0? Yes. All right, we can take that as part of our answer. And we're not allowed to make it equal to negative 2. Okay, plugging in 0, that's going to be negative, positive. Sign is going to be negative. No, that is not a solution. Plugging in 10, positive, positive, sign, positive. Greater than 0? Yes. Oh, okay, so that's part of my solution. All right, so my domain. The domain of f is going to be negative infinity to negative 2, not including negative 2, and then 2 to infinity. Okay, there we go, my domain. All right, so now for b, this time we're adding in not just a log, but we're adding the square root, which also has its own restrictions. So we need to take the and of their restrictions. So I know that this needs to be greater than 0, and x minus 2 needs to be greater than or equal to 0. Okay, the restrictions are just slightly different. This cannot equal 0, but you can take the square root of 0. That's perfectly fine. All right, let's solve this. All right, so let's graph these two on a number line. I'll do this in green. So x needs to be less than 7, not equal to, just less. And for this one, I'll do it in pink. X needs to be greater than or equal to 2. Okay, and this is an and statement, so I need to take where they agree, which is going to be just this intersection point here. So that's going to be positive 2 to 7, but not including 7. So that's the domain of H. All right, there we go. So remember, your arguments should always be positive. All right, I think this is the last page. Okay, so properties of logarithms. So there are, well, pretty much the same sort of properties going on here for regular logs and natural logs. Okay, if your argument is 0, if your argument is 1, your answer will always be 0. Because that's asking you a base to the 0 power is going to be 1. So remember, the answer is our argument. Okay? So this is saying a to the 0 power gives me 1. A to the 0 equals 1. So if you ever see 1 in the argument, you can simplify it to 0. All right, so I'm assuming you have seen some of these properties already, so we're going to go ahead and work with them. Okay, so log base 5 of 5 to the 4. Well, I can simplify that using this one right here. My base matches the base of my argument, which means in a sense they can cancel out, and I'm just left with 4 as my answer. Okay, this one right here. Well, 4 to the 64. Well, I know 64 is actually 4 to the 3rd power. So I can rewrite this as log base 4 of 4 to the 3rd power, which means I can use the same rule again, rule 3, and the bases will cancel each other in a sense, and our answer is 3. This is also saying, if you read this out, it's 4 to what power gives us 64. Okay, this problem here is reading 5 to what power gives us 5 to the 4th power. Okay, so that's how you can kind of read it off. All right, so C. Well, what's the base here? The base is 10. And this is saying 10 to what power would give me 0.1? Well, I'm going to go try use one of these rules here. So I want to change 0.1 into 10 to some power. Let's see if I can do that, okay? Then I can use this canceling property we've done before. Well, let's see. That's going to be log. I'm just going to write the 10 in for the sake of it. 0.1 is the same as 1 over 10, right? And 1 over 10, that is the same as 10 to the negative 1 power. And look, now the bases match. So, in a sense, they cancel, and we're left with the answer of negative 1. Okay, so if you can manipulate the argument to look and match the base, then you can simplify it. Okay, go ahead and give D a try by yourself. All right, well, I know natural log, the base of natural log is base e. So can I manipulate this as e to some power? Well, yeah, I know that the cube root of e is the same as e to the 3rd power. So there we go. And the bases cancel, and we're left with a 3rd as our answer. All right, so we're going to solve this equation. One thing to note, though, remember that log a of x, we cannot have a needs to be greater than 0, and a cannot equal 1. Okay, that was a rule back in the beginning. Sorry, x. Okay. Ooh. So you can go back and check the definitions earlier. Let me find it. Here we go. Okay, so a cannot be 0. A has to be greater than 0, and a cannot equal 1 when we're given this function. Okay? Actually, you know what? I'll just rewrite that. Why not? So if we have log base a of x equal to y, we know that a needs to be greater than 0, and a cannot equal 1. And we also know that our argument x needs to be greater than 0. All right, so solving this. Well, I'm going to change this into exponential form, okay? Because notice, where is my variable? The thing I'm trying to solve for is inside my argument, which at the moment means I cannot touch it. So I want to get it out of the argument, which means I'm going to change it to exponential form. Well, what is the base? The base is 10. Okay, actually, let me write that in black. So to change it to exponential form, that's saying 10 to the 2nd power is x minus 4. Okay, so solving this, that's 100 equals x minus 4. Adding 4 to both sides. I get 104 equals x. So let's check real quick. X is from my argument. So if I plug x into my argument, do I get a negative value? No, I get 100. That's positive. Okay, so it checks out this answer is not extraneous. It works. All right, let's check for this one. Okay, so this time, interestingly, notice my variable is actually from my base. For this one, my variable was my argument. This one, my variable is my base. But still, I want to be able to solve for my variable, so I'm going to put it in exponential form. So I can get my variable on the normal solving line, is what I say. So that's going to be x to the second power equals 100. Okay, so square root both sides to solve for x. Remember that plus or minus. So x equals plus or minus 10. All right, so let's see. But we have to check our answers with logarithms. 10. X was my base. And notice my base, it needs to be greater than 0. So this value here does not work for my x. I can't allow it to work. It doesn't work with my restrictions. So this one is an extraneous answer. So let's check 10. Is 10 not equal to 1 and greater than 0? Yeah, 10 works. Okay, so if your variable is from your base, you need to take into account these restrictions if your variable is from your base. If your variable is from your argument, you're going to take into account that restriction right there. Okay? When you're solving, be careful. So the base has one more restriction, but the argument just has that one restriction. All right, so that's it. Your written homework due by the end of the week. Please email me if you have any questions.